This is my third forces video, and it's about energy, mechanical energy. The first one, kinetic energy, half mv squared. I'm not going to derive that equation. Interesting, it was Thomas Young was the person who first came up with that equation. It comes from v squared minus u squared equals 2as, and then work is force times distance. And anyway, kinetic energy is a half mv squared. The kinetic energy of this dog is 216 joules. A little calculation you would definitely need to be able to do. If this dog has 400 joules of kinetic energy, what would its velocity be? So rearranging the equation, v is root 2ke over m, which is 8.2 meters per second. Make sure you can do this. This little equation pops up all over the place in A-level physics. Getting the velocity if you know the kinetic energy. Gravitational potential energy is mgh. That comes from work equals force times distance, mg times h. I think it's better to talk about the difference in gravitational potential energy. And until we do gravitational fields, basically if an object goes up, then it gains gravitational potential energy. If it comes down, it loses it. In a uniform field where mg is constant, then it's mg times delta h tells us the change or the work you would have to do against gravity if you were climbing upwards. Elastic potential energy, I've covered in another video, is a half kx squared. Stretching a spring, you have to do work. It stores elastic potential energy, a half kx squared or a half fx. Now, the principle of conservation of energy, very, very important in physics. Energy cannot be created or destroyed. It can only be transferred from one form to another, or the total energy of a closed system remains constant. Okay, consider this very simple example. A boy of mass 60 kilograms jumps off a wall of height 3 meters. What will his velocity be when he hits the ground? There's a few ways of answering this. You could actually do a Suvat equation, but what we're going to do now is what we call an energy equation. If you identify the energy transfer which takes place, so gravitational potential energy changes to kinetic, put in expressions for that, get an expression for the velocity, bung in the numbers, 7.7 meters per second. There are occasions when you can't Suvat. I mean, if the acceleration wasn't constant, then you can't use a Suvat equation. You might have to use an energy equation. Here's another question. A toy has a mass of 25 grams, contains a spring of stiffness 500 newtons per meter. The spring is compressed 4 centimeters. The toy pops up into the air. Calculate the height reached by the toy. Have a go yourself, pause the video, and here we go. There's my energy equation. EPE goes to GPE, and if you bung in the numbers, you should get 1.63 meters. Here's another one. A skier of mass 70 kilograms comes down a slope of 15 degrees at a uniform velocity. We're told the change in height. Write an energy equation, calculate the average frictional force acting on the skier. Now, you'll probably get this wrong, because most students do, because they think somehow in your energy equation kinetic energy is involved, and it isn't. The skier is not gaining or losing kinetic energy. They're going down at a uniform velocity. Your energy equation is the loss in GPE goes to work against friction, and the work against friction, you would need to work out the actual distance that they travel from the information that they're given. The distance, the length of the slope is 77.3 meters, and so the average friction force is 177 newtons.